Okay. Thank you, everybody. My name is Ryan. I'm going to talk about backend microservices in Kotlin. This is going to be kind of half a story of our organization and the journey that we took to get to adopting Kotlin. And then it would not be a good meetup if we didn't look at some code. So I want to show you all some code as well that's come out of it. First, introduce myself. I lead the technology team here in New York for N26. We're a European retail bank that is growing quite quickly. We launched in 2015 and today have over 1.5 million users across 22 countries in Europe. That number keeps changing. We are really focused on kind of eliminating a lot of the complexity and frustration that you encounter kind of in consumer banking. We're all in a mobile platform. You can download our app, sign up for an account, and transact everything you would do for banking through your mobile. We have quite a few people globally. So we've recently opened an office in Barcelona, and we're trying to launch here in New York, in the US. Next year, and that's why our team is working here, and we're also trying to grow. So I kind of want to first address the issue of, how do you bring a new language into an organization, and particularly with Kotlin, because there are specific reasons we chose Kotlin. But what we started with was we wanted to diversify our backends in terms of the languages. We were basically a Java shop, and there's a lot of interest among engineers to work in multiple languages. Java itself has drawbacks that I think a lot of people feel frustrated with, and we started to look for some other languages and other technologies to expand our tool sets. And we tried a few that didn't work. So first we were looking at Scala and built actually a whole service, a microservice in Scala, pushed it out to production, and started to look at how that would work. And it ended up being an uncomfortable experience because we really lacked a lot of organizational knowledge and depth in Scala, and we found that that combined with kind of Scala's propensity to have a lot of variation, a lot of different ways to kind of write the same amount of code, meant that it was difficult to maintain even kind of a single service. You don't want to be the person that gets on call, woken up late at night, and you can't even read the code of the service that's failing, right? You can't trace through the errors. So it's like a really, really frustrating experience, and you're just cursing at the authors of this. Why did you write this code? I don't understand it. And so, I think one of the things that we found was very important was that, we kind of had a common understanding of how to use this language, how to write code in this language, and Scala wasn't necessarily constructed that way or didn't have some of the kind of guardrails that we wanted to kind of introduce this into the organization. Another example was TypeScript. So we actually have services in TypeScript. Web services and front-end services. So there was some domain expertise here. It also happened moving off the JVM was quite difficult, right? And when you think about all of the things that are running your code that are not the code, the instrumentation, the library support, even between services, a service owners may publish a client. That client is only going to be kind of in the language of the service itself. And so Java interoperability became really kind of a critical concern when we started to look at languages that were off the JVM. I just want to say, I personally really love Scala. I wish I were there when they were kind of experimenting with it, because I think maybe we could have driven a different outcome. But again, I think we can recognize like the dangers of introducing a tool without a lot of expertise. So how did we do this? So, as we kind of mentioned, we looked at, actually building a service and putting it out into production. So that was kind of one attempt. Another was, let's try to identify some things in the organization that are in our tools that are in a stack somewhere else, and bring that into the back end. And really what we found to work really well with Kotlin was, let's try to experiment first with it. Let's not put it in kind of the critical path. Let's not put kind of production reliability at stake or at risk. So in 26 we call them GSDDs, so it's get stuff done days. And we run them every quarter. And a group kind of came together and said, well, we really want to experiment with Kotlin. This was going to be kind of our output was going to be just writing some Kotlin code, learning about it, trying to evaluate this as a potential language to bring in. And it was immediately very popular. I think anybody that's come from Java and starts writing Kotlin starts to kind of feel just a wave of relief. And we were able to start using it because of its strong interoperability in our tests. And so, tests aren't code that's going to execute in production. So it was a great way for us to start having it in kind of a real service and a real part of our system, but not as risky as it being kind of a production code path. I would also say, we were a little bit lucky in terms of timing. Spring Boot 2 started supporting Kotlin around the same time. We had Spring Boot is quite ubiquitous across our backends. And so again, this was a way where we didn't need to change a ton of our tooling, the CI/CD pipelines, everything we were doing for building, monitoring, the test suites, all of that stuff kind of was baked into our Spring applications. And so we were able to, once we got comfortable with the language and started adopting it more, actually build it into the service code without sacrificing a lot of that other structure. There's still some gaps here, I think, and don't quote me on this, but I think Lombok still has some weird support with Kotlin, but we've been able to kind of work around it, and today almost every new service we're writing is written in Kotlin. An interesting side note, and I think most of us know Kotlin, the normal context for Kotlin is Android applications. Independently, or maybe not independently, I'm sure they heard what we were doing. They started to experiment with that as well in the front end, and today half of our Android apps code is in Kotlin, and the goal is really to continue to kind of expand that coverage. So we're really glad to be using it on both platforms, but I think the backend is a place that tends to be not as much talked about, especially in online resources. So I'm glad we're able to present that today. So what is great about Kotlin in a microservice context? Well, a lot of times microservices, you're just shuffling information around, right? You're making a request to something, getting some data back, you need to serialize, deserialize it, you've got kind of structs or JSON or DTOs and data classes, and some of the ways that you can kind of use the inheritance and the kind of the components of the interfaces makes it something simple. So I think a traditional approach in the Java world is I need to do something, let me go find a library that does this for me, right? I need to serialize a struct into CSV, which is what this code does. I'll go find whatever the coolest CSV library is and bring that into my class path and start using it. Well, actually doing this yourself is really easy and a short amount of code. I mean, one of the biggest advantages of Kotlin, the most touted, is how terse it is. And that makes this kind of code still arguably boilerplate, but a lot easier to kind of digest and understand. And so, in this, 30 lines of code, I can attach some companion objects and interfaces into my data class, and now this thing serializes and deserializes into CSV. Very simple, straightforward. The code is easy to understand and is quite defensive. You can kind of take this even a little bit farther and do JSON. So I've personally struggled with Jackson dependency hell, right? Like getting Jackson out of my project is amazing. It's a personal accomplishment. So again, this kind of helps me to do that because I can use more primitive JSON libraries like JSON object from the org JSON, and again, you know, have some very genericized types and methods, and again, be able to serialize and deserialize these simple structs very quickly. Again, I think there's advantages to when you have very complex objects or complex DTOs. This isn't a great approach. But for simple things where you're just pushing some simple data, not very nested or not very relational data between services, this works great. And again, taking advantage of some of the inlining and the covariance of Kotlin, being able to define methods in interfaces, so reducing the redundancy of that code. And then this is what is necessary then to basically turn a string of text into a data object, a data class from JSON. So this was really nice. I mean, it just kind of, again, in the microservice context, it's just like things you repeat over and over and over again, and you start building up a lot of dependencies in your POMs or in your Maven archetypes, and then you start to get into version conflicts. And so kind of being able to do some of the simpler things in a cleaner, more straightforward way was a big advantage for us to kind of simplify some of these dependency trees and some of our service code as well. Okay. This is a little bit harder to understand, and I'm not sure I completely understand how this works. So this is in Spring. We're using a Spring annotation here to annotate this as a component. So this is kind of an example of where you can start to do maybe more functional coding style, but also use Spring's dependency injection so that you continue to maintain kind of the testability of code, the code that's decoupled and componentized. So let's talk about what's happening here. So this is a class that parses a file, right? And it takes as a parameter a list of validators, and then it exposes this method parse, which takes a string, splits it into lines, runs each line through a validator, and returns a class representing this file. This component would be one of the validators that is being run, and this would be injected, using Spring's dependency injection. And what you might have already noticed is this line right here on line 4 looks a little strange because it looks like we're taking a list of a class, but then we're using an instance of that class. And so what you've probably started to connect to is that that's related to the invoke operator that you can override in Kotlin. And then if you've connected all the dots already, what you'll notice is that this interface, its return type is a function. It's not a class. So what is being done here is injecting a function into our parsing class. And that's a function that we can invoke. And this function also has a context to it, which is a constructor variable that is used when you're creating that function. So a little bit, and honestly, there's like debate about how good this is to be using. But when you kind of wrap your head around it, it starts to kind of make sense. And when you go and you look under the scenes of how this possibly works, what you'll see is, so what we're comparing here to is something similar. So this is a class that's typed as a function. We're comparing it to a lambda, so this is a traditional lambda declaration here. And when you decompile this, you'll see what it's checked as is the same. So Kotlin is turning both of these into instances of function 1, which is kind of a fundamental part of how some of the lambdas and the invoke operator works. So again, like I said, we're still kind of debating the value of this because when we first started to look at this, we couldn't understand what this code could possibly mean, right? Like this is very incongruent. I have a list of this objects of this class, but I'm calling it like it's a method. And we're still not quite sure how to reconcile the readability of this, but it's an interesting, I think, intersection between some of these advanced features and functional flavors of Kotlin and a Java framework like Spring and Java kind of code style, which is using dependency injection to improve the testability of your code. Anyway, despite of that, we're still going to continue to use Kotlin and emphasize it. And I think some of the things that we're really looking forward to getting deeper in, certainly the ability to create DSLs. We have kind of services that are very easy to express as a DSL, right? Like we need to notify our users after the receipt or the publishing of an event, and this event needs to map to this notification at this time. That's something that's simple enough to express in a DSL, so we can kind of have a very generic notification service and configure that in a lot of different contexts through DSLs for very narrow services. We also really are excited about some of the micro frameworks. I mean, honestly, like Spring is just too overloaded for some things. We want our microservices to be micro, and there's been a lot of good activity there. I think, as you mentioned, KTOR entering 1.0 is really really good. We started to adopt AeroCore, so this is some of the kind of functional third-party library that kind of encapsulates things like optionals and a whole other suite of things. So that is already kind of teams are already bringing that into our dependencies and code base, and that's exciting. One of the strongest proponents of adopting Kotlin had this interesting observation. He's like, this is a great language to start to teach people functional concepts and functional coding paradigms. And I definitely agree with that because I've tried to learn Scala for 2 years and I still don't really know it all. So I definitely agree with that, and I think that that's kind of an important consideration in a large organization, is how do you improve your engineers and teach them new things when they're spending most of their time coding? Well, we bring in something like Kotlin and start to do it slowly. And then, of course, with coroutines, a lot of things in a bank are easy to model as event-driven, right? Someone deposits his money somewhere, a balance changes somewhere else. Like the classic, event sourcing examples are always banks, and that's for a reason. It's great to model this, and we're definitely looking to take advantage of that, especially in the context of coroutines. So, a few takeaways, right? We definitely learned some things, and one of the first ideas was that Kotlin is a safe language. It's not too powerful like Scala, so you can introduce it safely and your whole system won't fall apart. Well, you start to write it for a little while and you get a little clever and you find you can abuse Kotlin, right? And so I was constructing this chaining disaster, this is actually not the worst that I've seen. Like, I can't grab our code. Our code is worse than this. This is an easy example. But like chaining and then some of the inferred typing allows you to do some very hard to understand things. Like what is the return type of this function? Well, I mean, you can kind of get to it eventually, but it's not immediately obvious. Constantly putting developers start to think, oh, maybe I can get rid of writing if statements, right? I'm just going to do lets and else operators everywhere, right? And look how cool, this is all done on one line. It's one line that takes 80 lines in your IDE and is really tough and from a readability perspective. I'm not sure any language should be purported as safe unless it's quite powerless. You always kind of have to keep good judgment and push back on code that is clever but difficult to read and maintain. The other thing we've encountered, it's a developed language. It's being developed, right? So this is some code that takes advantage of a loophole in some of the reflection libraries, where You can actually pull a property value out of a class based on its name. You have to kind of go through the Java reflection back to the Kotlin to actually get invoked to compile. If you actually did the second one, I don't know if you can read it, but you can get to declared members just straight through the : class. That won't compile because of the variance and the type checking. And it's not really clear why this exists, or this difference exists in the language. Like if you go and look at these two things, the one that compile is calling this get Kotlin class, and the one that won't is calling get or create Kotlin class. And not really sure why. So you always have to be kind of mindful of, well, this is a language that is young and is being developed, and some of the benefits are offset by the risk of running into odd scenarios. Hopefully most of them are like this and are caught with a compiler, but I'm sure there will be some interruption that is a result of something weird in Kotlin. It's just bound to happen. It hasn't been around for 20 years. Some of the other takeaways is like, how do you learn a new language when no one in the organization knows the language because the language itself is young, right? So this is true for what we try to do with Scala and any other new language, but collective learning is especially difficult when the language is young. You don't have all the resources online. You can't go and hire a veteran or an expert in this that's been doing it for many, many years. So you're all kind of doing this yourselves by like learning as you go and just trying things out in code and experimenting. And then how does one person who learns something or finds something novel communicate that with his peers? Maybe someone who's not on his team. So how do you disseminate that information throughout the organization? How do you have debates about what are good styles or not? So all of these things, you need to be kind of aware of and be prepared and plan for. You need to have forums where you can share learnings. You need to be more proactive about publishing best practices and code styles and those kinds of things. The second one is just a little personal thing. Like we could spend the next week talking about checked exceptions and unchecked exceptions, but you do kind of just keep that in the back of your mind, especially when you're trying to interoperate with Java. That's something people kind of overlook. But I think the last point I want to make here, it's the reason why we're all here. The community is a huge aspect, I think, of this language, and we continue to see just excitement, enthusiasm, and a lot of participation. And we were able to attend Kotlin Conf. We were able to send a few people. They had a great time, and they came back with a lot of interesting things. So, I think that we're excited to continue to participate in this community here in New York, and as we grow out our team.